Hello and welcome to yet another interesting conversation from the series of interesting conversations on our channel. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios, and my guest of today is somebody who is an author, who is a speaker at many conferences talking about DevOps and infrastructure automation, somebody who is a programmer but has been very interested in infrastructure, and an author. He published a book called Groovy 2 Cookbook. Welcome, Andrey Adamovich.
Thank you very much. Thank you very much, Alex.
Before we go into a few topics, it would be interesting for our audience to learn more about you. So how did you get into programming, and perhaps even more interesting, why are you so interested in this part of infrastructure automation and not in building applications or something else?
Right. Well, yeah. If speaking like the history of me is like I started in previous century, like you, Alex, as well. And yeah, I mean, well, I kind of was always interested in computers, and I think that interest was, kind of boiled a bit more when I got my first computer, which was IBM compatible thingy that was a Soviet-made thing, Soviet-made computer of like some model which was compatible with IBM stuff. And yeah, that got me interested, and since then, since 1992, 1991, I'm constantly doing something with computers. And to be honest, I mean, you mentioned that I automate infrastructure, but I started as a developer, and to be honest, I still consider myself as a developer. I'm still writing code, so it's not that I gave up on writing applications. I still do write both Java and Python, and sometimes Ruby. It's just that the focus shifted a bit, but I'm still a developer, still writing code, and still actually taking that mindset into infrastructure world when I'm trying to apply the same testing techniques, the same code organization techniques like clean code. It's important on any level, anywhere you have the code. So it's so I'm still a developer. I still consider myself a developer.
Well, and I guess this is what is common when we talk about infrastructure automation or DevOps today, is this merging of infrastructure and bringing code into that. But I see a lot of organizations and a lot of teams that don't fully understand this idea, or that don't take it to all the way. And it would be interesting to have a quick chat about DevOps and how it's understood in organizations, what you see when you work with teams. And
yeah, well, actually, yeah, it's interesting that it's actually evolving, because DevOps as a term appeared like 10 years ago about that, and of course at that time it was like new and shiny, and a lot of discussion was happening, and it was considered like unicorn kind of thingy that nobody else was like the big old fat enterprises were not really doing. But now I think it's really changing and improving the industry. So judging from my conversations, because I have lots of clients in different areas, mostly in Europe, and I really usually help them with automation and helping them with bringing these different worlds together, like operations and development. And actually, like 5, 7, 8 years ago, it was way harder, because many people didn't really realize that automation is the key. Automation is the way to go, and actually is a way to save a lot of money and actually get a lot of momentum for a company to jump to the next level. And many companies were not really understanding that. And but now kind of we are in a different cycle. Now everybody wants DevOps. Everybody wants to have that at least somewhere in their like CV or in the white paper of the company. Everybody want that label or badge. We are doing DevOps. We are a DevOps company and stuff like that. But also the understanding of what it is actually changed. Actually, the more I go now to the companies like this year and previous year, the more I see that people actually understand what it is. And to be honest, of course, there are still people who are thinking that it's just about tools or just about new shiny cloud native stuff, when it's quite often it's not. And that's the thing I'm saying quite often to my students, to my people who attend my courses, and also to my clients, is that tooling is not a problem in 2020. We have so many. We have pretty much a tool for anything. But there are many other problems that are still unsolved. And DevOps, in its original form, back in 2008, 2009, 2010, was actually trying to solve not the tooling problem. It was trying to solve the problem of bringing two different approaches together, to bring two different perspectives together. The perspective of developers, like who were willing to develop new features, to deliver new functionality, to do some sort of new things for their customers quickly, but also the other world, for the operations world, was trying to keep all these things stable. And I think we as an industry, slowly, steadily, but slowly, we're going into the situation where we actually want to have constant development, constant introduction of change, like that. Agile started that to some extent as well. And we also want this change introduction to be as stable as possible at the same time. And of course, without ideas that were feeding DevOps, it actually is very hard. And unfortunately, I mean, some companies, some managers, some developers, some sysadmins, they still don't understand that the idea of Agile, the idea of DevOps, the idea of Lean, were actually to be as adaptive to the change as you can be. And of course, DevOps brought kind of the technical part of that. They brought in more the tooling importance, more the automation importance, but still the main point was not the tooling. The main point was still to get fast way to adapt to the things that are changing in the world, and try to allow your company to be as stable as possible when you are changing things. So that's the idea of that.
Yeah, and I think the interesting part with DevOps, if you for agility, you can make a case that perhaps not everybody needs it, because if you are working in a more stable environment where requirements don't change that much and so on, perhaps you don't need to introduce so much change. But with DevOps, one interesting thing is that it actually helps with stability, with scaling, so getting actually more value from the things that you already have. But in order to do that, you need to invest a bit, not only into the tooling, but also into the training of the people, right? I mean, I remember at one of the courses where we've been together, that we were with a number of system administrators who found very hard to write code. Is this a common thing that you see?
Less and less, but yeah, it is still quite common that well, I'm not sure if we can call them like that, but like traditional system administrators were supposed to just maintain the boat and don't do much innovation in there. For them, especially for those people who were in the industry for like 10, 20, sometimes even 30, 40 years, for them it's really hard to get into this coding perspective of infrastructure, and it's hard for them to write scripts, or it's sometimes, well, maybe sometimes for them it's not hard to write scripts, but it's hard for them to write scripts that are readable, and they're not really used to this discipline of writing code that should be given to the next person that comes after them, and maintain that script and maybe improve that script, and sometimes they even treat this code that they write as their own baby, as their own creation that is only supposed to be theirs. But unfortunately, the life cycle of code in a big organization, in an older organization, will be that the code will be given to the next person, to the next team, or maybe even deprecated, maybe even like thrown away. And we have to take all this consideration into account when we write code. And yeah, unfortunately, not all of people who have like traditional system integration experience, they have this mindset of, let's say, knowing Git as a version control system, and using Git as a way to, see to track the changes and track the history of things that are happening to the infrastructure. Yeah, it's still there, but to be honest, it's definitely improving, especially with new generation of sysadmins, new generation of, like, if you can call them DevOps people, automation engineers. Definitely, people are more proficient with scripting, with coding, with ideas behind creating qualitative software product, whatever it is, infrastructure as code or application or testing or whatever. And well, you probably heard of this term like DevOps engineer, which I don't really like, because DevOps is, if you look at the definition of DevOps, it's about a lot of things, and engineering is just only part of that. So if we're talking about DevOps engineers, we're really not defining anything. It's just, you know, some abstract profession that doesn't really well, to me, to my taste, it doesn't really exist. But unfortunately, the industry kind of picked up the term and they're using that. So to be honest, my opinion on that, it doesn't really matter anymore, because the industry kind of picked it up, and people will continue to use that. So I would actually define DevOps engineer as like sysadmin 2.0. A person with experience in coding, a person with understanding of not only how his specific part works, but also how the whole organization is working, and how his actions actually are affecting the different areas, and what kind of role are they playing in the delivery of the product, of the business value that company is producing. So that's what I think is happening. And the traditional sysadmins who are not coding and not doing anything in Git, that profession is dying. The new sysadmin 2.0, which mostly people call DevOps engineer nowadays, is coming in, and that will replace the old generation, basically.
All right. So if we go back to what DevOps was and is, I think there are two important parts, and one of them is culture, one of them is tooling. Can you detail a bit about culture? Because then I would like to go into tools also. I know it's not the most important part, but there has been a lot of development there, and it's a bit confusing sometimes.
For tooling is easy.
Yes,
it's important, but it's easy as well.
So in terms of culture, what would you say are the elements that help you do something with this concept that actually helps an organization?
Right. I mean, I can actually describe what I usually do when I come to a new client. And the first thing I'm trying to understand is, usually I come from the direction of helping with automation, and I'm trying to understand why we need this system, for example, the one that they are kind of struggling with supporting, or may need to automate to some extent. I'm trying to understand what kind of other components are involved into actually using that system. And quite often I find out that people are blindly supporting something that nobody actually cares about. So there's like some old data storage or some old server that they kind of, somebody at some 5 years ago told them that we need that, and they constantly support that, update that with new patches and stuff like that. But the value that is brought by that machine or set of machines is pretty much zero or even negative sometimes. And so there's quite often that, especially if I come to some bank or some very old company which has like a lot of traditions or processes, it's quite often you can find a lot of things that actually do not bring any value. It's just people get used to that they're there. People get used to the thing that things were like that for before them, things will be like that after them, and they just blindly support them because they get paid for that. And I think this is the main thing that holds many organizations back. They don't try to revisit what is actually bringing value. They blindly following the procedures. Their inertia is quite big. And my initial goal is to try to find out where is the inertia, where is the thing that is holding them back, where is the main pain point, and try to solve that. And if I can remove some pain or some useless component with some digging in and analysis, then this first of all this brings this kind of builds trust between me and the client, but also it kind of continues to build trust also between the team that I'm supporting and the other teams that are working in the company. And then by building that trust, by building things that are actually helping people, not just because we need to do the upgrade because we have an old version of Red Hat, and but we don't really. But at the same time, people don't even know that the system is not used by anyone. That's that's kind of bringing. Yeah, I've lost my thought. but
yeah, so basically you are building trust by finding out the actual valuable assets, let's say, that are deployed and that are worth maintaining in time, right? It's not I understand that because, and I think that the issue often is that this is a different department, right? And you hand on, once the developer finish what they are doing, they hand over, and then the department gets a bunch of things to do in order to maintain that program, and they keep doing that, and nobody tells them, oh, we don't need that anymore, actually. I think that
exactly. And but you also mentioned another thing that is quite important is that devs and ops, they usually, or not usually, not anymore, but definitely still happening, and definitely happened in the past quite often, that devs and ops really are really aware different departments with different management, different types of management, different types of leadership, different types of life cycle, that what they do with the product, and that definitely held back a lot of things that could have happened in the company if they were working in a more collaborating way and more automated way as well. And quite often also, when I'm trying to start understanding what's happening in the company, I'm actually building both. I'm inviting both parts of this chain flow, both developers and operations guys, or sometimes I invite them in a different meetings, sometimes together, and it's quite easy to see. But when they complain to you about what kind of problems they see in their organization, quite easy to see where is the problem in the flow. Because quite usually the flow is broken. There is a blockage of some sort that is happening, in a way to deliver the new features and new product to the customer. Just ask people around and ask one side and the other side of something that's supposed to be a flow, and you will they will just tell you exactly where the problem is. And usually it's lack of automation, lack of reaction time, lack of clarity between the people. And quite often it's when I come to these kind of companies which need my help, these people who are kind of working on the same product, they're working on the same company, they don't talk. They don't talk at all. And they complain about each other, but they pretty much not talking at all. And that's another problem that any DevOps engineer or sysadmin or developer will never solve unless they start talking. And that's a huge issue in many companies, unfortunately.
Yeah, I've seen this. It is very common. But yet another thing that I see, one reason why I understand that sometimes it's difficult to make changes with infrastructure in particular, is that you are running, besides those things that are not important, you are actually run things that are actually important, and that often the whole company depends upon. And so coming with a change can be a bit problematic, especially when you are in the situation that you need to fight fires all the time. And what do you do? Have you seen such a situation? Can you make a change if you are always firefighting and trying to keep up, things working? And
yeah, absolutely. I've seen this one, especially last year I was in a bank where they actually have a system that is 25 years old, which is written in I don't know when, and they still have people with in their 60s supporting that system. It's not COBOL, but close to that. And for them doing a change is really a hard, at least 1 day activity. So the whole team is there when they do a change in the system. And to change that, the reason they are in this situation is because they didn't make a change 5 years ago, 10 years ago, or maybe 15 years ago, because there was no culture of reevaluating what do we actually using here. Is it really useful? and does it actually impose a new risk? And that's what many software companies have to manage different types of software, develop different types of software. They usually don't manage risk. And sometimes they think that if they postpone this upgrade, if they postpone this rewrite of the system, or if they postpone in direction of the new system, they will kind of reduce the risk. And in the short term, it will work. In the short term, it will definitely reduce the risk. But if you postpone this for 5 years, for 10 years, for 15 years, then obviously the risk that you are bringing in is much bigger than the value of the system that you're supporting. And you have to pay more and more interest rate on the risk that you kind of introduced through all the years. And that's, well, unfortunately, this case, well, you have two options, of course. You can pay these people who still have knowledge about the system and hope that they will not go away or unfortunately maybe die. And then they continue supporting that system until huge disaster happens, or you actually will make an investment of replacing the system gradually while you still have a chance. Because it's like the water dump that is blocking the river. If there is a leakage there, I mean, if it's a small leakage, you probably can survive few weeks, maybe a few months. But if you don't fix that, disaster will be quite big. And that's what's happening with software systems. I mean, if the software system is not participating in the cycle of consistent updates and reevaluation of its usefulness, then the risk that is accumulating, the technical debt that is accumulating, is becoming bigger and bigger, and you eventually will have to pay for replacement of the system, or for maybe some bigger disaster, much bigger amount of money. And that's another thing that many software developers don't understand. Many team managers, so software team managers, don't understand. Even many CDOs don't understand that in the end, it's all about the risk management and about the money that you actually are, like, about the future money, but the money that you may spend or may not spend. And sometimes you may need to do the investment earlier in order to avoid the risk in the future. And in some cases, like, this will work for like 5-10 years, but in some cases you just have a disaster.
Yeah, and this is very hard to recover, but fortunately you have today more tooling, more options, more. I'm curious though, who is more likely to learn these techniques? Is it more likely that a system administrator will learn how to write the code or how to automate infrastructure, or is it more likely that you'll get developers who also get interested into infrastructure?
I think both. I mean, I've seen both cases. And well, the most important thing here is probably not how old are you and what kind of experience you have, but more like how much passion you have for the profession, how much you value the place where you work, and how much the company is valuing you. Then if you have this, enthusiasm and passion about what you do and trying to make it better, then, well, sysadmins will learn coding, and developers may also jump into the new areas and bring new perspective, new ideas into infrastructure world. That's basically what happened with DevOps, because many of the people who are like the thought leaders in the beginning of DevOps, most of them actually were developers. Some of them, like, well, if you probably heard Patrick Dubois, the guy who actually invented the name DevOps. He's a sysadmin, but still he was like core sysadmin and was kind of jumping into this world of agile development and was kind of trying to achieve that in a better way. But many other people, like Andrey Adamovich and many other people who were in the beginnings of, like, in the discussion, what is DevOps? They were actually originally developers. They have this development mindset, which they brought in.
Yeah, that's interesting to me because I find infrastructure fascinating. Because what I find very interesting about infrastructure is that you can also pick pieces that are already made, kind of glue them together and make something that works. And then it's almost everything that you need to do is infrastructure, is caring about having backups, having scaling properly, performance, security, all this kind of stuff.
Yeah.
And this is very interesting today. And I find it's more on the line of thinking like an engineer rather than a crafter.
Yeah, exactly.
Rather than trying to build everything by yourself, is more like let's try to get some value and solve some problems. And I'm curious if you have, that's one of the reasons I wanted to ask you about your interest in infrastructure. Do you feel this kind of thing? I mean, I like to write code as well, but it was much more fulfilling to kind of put things together and they work and they bring a lot of value.
Well, I mean, yeah, I definitely like it because I still do that. It's just, you know, but sometimes when I'm working with infrastructure, I really miss the speed of the feedback cycle that I get when I'm writing an application. When we can write a unit test, and I can play with the model of my things I'm trying to program, and then the feedback cycle with like application code is pretty fast. I mean, it's like usually a few seconds, and then you can easily play with that. When infrastructure is a bit longer sometimes, because if you deploy a new part, like a new type of infrastructure to, let's say, to the cloud, and you want to really make sure that it works, then it could take, well, at least minutes. But sometimes it could be an hour before you fully like reprovision the new thing. You tested that, and you now realize, okay, now it's working. Now it's like it's correct, and then you did it another couple of times to verify that all use cases are covered. But still, I like infrastructure because I really, you know, because, well, when I started with that, well, of course, there were people who were supporting infrastructure in the team where I was, but what I realized, they actually were not that good at what they were doing. Well, everything took them like weeks to get a new server, to provision a new thing, to actually develop an environment for the application that we were developing. And at the same time, they also had a lot of other responsibilities that were not related to the project. So I kind of, you know, I took over because they didn't have time and they didn't have sometimes skill set. And also they didn't have a full understanding of what the application was doing. And to be honest, they shouldn't have had that at all. So and that kind of get me interested into actually making something that is designed for the application that we were developing, and automate that. And that was my like first success story that in DevOps and continuous delivery, where we basically had a full continuous delivery pipeline, where the whole infrastructure, the whole setup of the project, and it was a few servers with several applications. The whole thing was redeployed within an hour. Well, I mean, it's still a long time, but if you look at the amount of code that was put into that, and the amount of stability that we brought into the project, we could get fully fresh new environment in an hour with new version of everything deployed to that. And in 2010, that was like awesome, fascinating. I mean, it was so, and at the same time, the pipeline was so stable that our manager, she was releasing the new versions just by pressing a button on Friday, and it worked most of the times. And if it didn't work, she pressed another button to roll that back. And I mean, that was an amazing experience, something that I still like and trying to achieve in every project where I'm participating. The feeling of flow, the things that I'm actually another reason why I'm kind of interested in infrastructure is that usually when you introduce the pipeline of delivering things and creating environment for your applications, and that automation works, then usually that pipeline becomes very stable. Then after the first initial maybe weeks or months of experimentation, it becomes very stable, and you don't need to do anything with that anymore. Developers continue working, they just commit the code, and that code ends up in, well, at least in development environment, but in the best case, in production in a few minutes or maybe an hour. And having this feeling of giving other people an ability to deploy things quickly and giving them feedback quickly. That's what keeps me in. Not just infrastructure, but actually in continuous delivery area or zone of our world, because that's really nice experience and nice feelings when you can give it to people.
Yeah, I agree, and it's always been great to see. Nowadays, if I start a new project, and I know it's taking a bit longer, I will always start with setting up the infrastructure so that it's automated and I don't have to think about it. Because, as you said, after a few weeks, it gets stable, and then it's just, push, and things just work most of the time. Except when you need to add some additional things, but then once again, it's cool. I wanted to ask you about the feedback thing. So part of development, we also have these techniques like test-driven development or refactoring. And I've seen them applied to infrastructure, but you have a longer feedback cycle there.
Yeah.
And what is your opinion? Are they useful? Can you use them properly? Is it worth the waiting for the longer feedback cycle to have tests and to properly design your code?
Well, in my experience is that of course I've seen quite huge infrastructure as code bases, like literally thousands of lines of Terraform code and Ansible code and Bash scripts, which are extremely hard to refactor, because what the team ended up creating is a monolithic piece of code, which is hard to break. And we've seen the same thing in application code. Like quite often, if the project is old enough, then people tend to create a huge monolithic code base, which is very hard to break into smaller parts. But if you keep this thing sane, if you keep an eye on the size of your application or of your infrastructure as code base, and split that code base into smaller components, fast enough, or at least not late enough, then you can actually quite easily refactor things with infrastructure. Because I guess you also have seen a lot of big monolithic code bases, which are very hard to refactor because maybe dozens of people work on them, and there's so much spaghetti code in there that it's impossible to find out where to split that code base and make it more efficient. The same thing happens in infrastructure as code. But if you as an architect or as a DevOps engineer or as a team leader for your team of SREs, like site reliability engineers, notice that early enough, so that the complexity is growing in certain parts, and you manage to split that, then it's actually quite easy to refactor. Especially with modern cloud technologies, where you can basically create another account in the cloud or create another namespace in Kubernetes, and just reproduce the same setup. And when you're happy with your refactoring, just migrate anything that is valuable to that, like data. Data, of course, should be migrated. You cannot really refactor that. But the configuration, obviously, you can easily reproduce that in a new isolated environment, and play with that, test that, verify that it works as you suppose that to work, and then migrate. But of course, the life cycle, like the time that you spend on that, definitely is bigger than the time you would spend with the usual applications. And also, you have to plan the migration if it's needed, which may be a bit time consuming, but in general it became way easier with virtualized infrastructure and cloud providers, and especially if you keep an eye on the complexity of your code early enough, then it's becoming easier to isolate these things. But also another thing that is happening, that is also quite a good thing, is that different tools like Kubernetes, Ansible, Chef, Bash, whatever, they have lots of like huge communities behind them, which are creating packages of pre-made components. So if you want to install something, that already is tested and pre-made for you. Like if you want to have a library for installing certain database product, you can get it. And you pretty much get a very qualitative tested product that you don't need to spend any time changing or writing. You just configure that a bit to your use case, and that's it. So this infrastructure as code world is definitely it's a huge community of people who are, well, pretty much like developers. And I would say they are developers. They are developers in many ways, who are writing components, libraries for DevOps engineer in a real company. Just take them, combine them, and reduce the amount of code that they have to write in their company. And that's a good thing.
Okay, and this takes us to a few, let's say, more concrete problems that I often hear from managers or from the teams, or that I thought of myself related to switching to this way of thinking. And since you mentioned the existing components that you can just grab and use, one question that comes to my mind is, can you be sure that those are secure? That there aren't any hidden things, inside those components that expose your data or expose your services to hackers or.
Yeah, but usually those components are open source, and so some of them are not even compilable. So you for example, if you get, let's say, some sort of Helm chart for Kubernetes, that's basically a bunch of YAML files which you can look at and review yourself. And so of course there's quality concern that not every open source package is of high quality. Some of them really are, because there's a huge community of people supporting them, and maybe even a company who is kind of putting their money and time to support the component, but offering that as an open source product. But most of the things that you can use in infrastructure as code kind of tooling, most of that is open source. And actually, returning to the culture thing, many companies actually lack that culture of selecting the tooling. Some of them do not evaluate the quality of open source component, just inject it into their code and start using. Some of them don't evaluate the security, and they just get that and then get a hole in their networks, for example. But they have all possibilities to actually do that. That they can on GitHub, on GitLab, or many other open source platforms where we can see the code. We can see how many people are in the community of this specific component. We can see how many issues have been created. We can see how many issues have been addressed. We can see how often a release are made. We can see how this thing is supported by other communities. How maybe some other projects are using that. So there's a lot of possibilities to evaluate whether this component is good or not. And definitely, if you are concerned about security, then you have all the thing, or everything at your hands to actually evaluate that and understand whether it's secure or not. But in most cases, I mean, if it's a component that is developed by, let's say, hundreds of different people and reviewed by maybe even more people, then there's a high chance that there is, at least people have thought about that, about security. So it should be there.
Right. Another question that comes to my mind is I've often worked with companies that have a licensed proprietary CRM, or 3 of those, or 5 of those, or an ERP, or 5 ERPs that are licensed, and it's very hard for them to replace these systems. Even if they want to, it takes a long time and so on. How does this fit with automating infrastructure? Because you may get into some clashes there.
Yeah, it's hard. It's hard. It's definitely hard. And I also have seen this kind of situations when for companies, it's really hard to migrate from their old bare metal machines standing somewhere in the basement where they run their super important ERP system. But if you try to calculate how much money actually is lost on supporting that system, like how much and how much risk it actually is involved, and what if the system is broken, sometimes you can actually convince the managers and the financial people to actually allow you to cover that risk, to kind of cancel the risk and then reintroduce a new system. Of course, I mean it's good when people realize that the problem is there and have a plan to kind of replace to fix the problem, and maybe it may take sometimes months, sometimes maybe even years. It's just that people have to have this culture of understanding that software components they rot all the time. Especially if you don't update them, if you don't change them, if you don't do anything about them, they will not adapt to the new things that are happening in the company, happening in the world, and you will have to replace them eventually. If the company has that culture, they have at least this gene of understanding that things are as volatile in software as they are in hardware, or they will eventually get into the point that they will slowly replace these systems. But it's hard, especially with old companies. It's hard to convince them that, well, it's a huge risk, and we have to address that. Well, maybe not as soon as possible, but we have to address that, and we have to have the budget for that.
Kind of on the same line, but it's perhaps an even more difficult decision, is switching to some kind of a cloud system, because you have now all those benefits of AWS or Google Cloud or Microsoft Azure, which bring you, as you said, a server in minutes, and you can deploy stuff there, and you can have a feedback in 1 hour and so on. But if all you have now is bare metal, and if you think that that might be a security or privacy risk, it can be quite hard. What have you seen in terms of this kind of change towards cloud adoption?
Yeah, there's usually resistance, especially from old traditional sysadmins who are blaming the cloud in any possible scene that you can think of. It's not secure, it's not reliable, it's not fast enough, it's not good enough, it's a different way, it's expensive and stuff like that. And yeah, the transformation of going from on-premise to go into the cloud. Actually, I would say that it's not needed for every company, because some of the companies are quite good at how they actually maintain their bare metal, and some of them started 10 years ago, 15 years ago, 20 years ago, and they actually became quite good in managing what they have with bare metal, and they have skill inside the company to manage that things, and automate, and actually to serve the business value in a good way. But also there are companies which are just accumulating this old bare metal machines, I actually just recently, half a year ago, I was in a company that still run lots of Spark machines, like, this old machines from Sun. And actually last year they even bought new ones because they wanted to, because there was some software component that was only running on Solaris. And they just needed to expand the capacity for that component to have to serve more requests, and they bought a new Sun Spark machine, which is not even produced by Oracle anymore. So it's kind of the question is, why did they do that? And yeah, it was quite costly for them, and they still did that because it seemed to the management that rewriting the software was more expensive than buying this new old machine. And if you try to move these discussions about upgrades or removing some of the legacy systems into the plane of money and economy, sometimes it becomes more obvious that certain things are actually way more expensive than what people think they are. But it's quite important to also understand whether your company has the skill and the people to support what you have. And quite often, especially what I've seen from traditional sysadmins, is that they say that let's say bare metal is less expensive than the cloud. And if you compare just the hardware part, actually they are right. If to buy hardware is less expensive than to rent the hardware for let's say for the same period of time of amortization time in the cloud. Cloud will be more expensive. But at the same time, you get additional services with the cloud. You get replaceability, you get redundancy, you get additional services like monitoring, backups, elasticity if you need that, and also you get geographical redundancy. So it's a lot of things you get for that price, not just the hardware. And then if you compare that, sometimes people say that, okay, but we don't need this service that the cloud provides, we just need the hardware. Then the conversation boils down to the fact that, but do you have the skills to actually provide what your company requires to the teams, to like development teams or business teams that kind of use this hardware? And quite often the answer is no. Quite often the answer is that we cannot deliver, and we can actually compare how often the requests are coming for the new hardware or for the new capacity, like for new database space and stuff like that, into the teams that are supporting them, probably supporting them on bare metal, and how big is the reaction time? And usually it's like sometimes it's weeks or maybe even months to get a new capacity, and how long is, let's say, the release cycle for a new database schema change? And quite often it is hours, or how big time, how much time does it take to actually make a backup? And quite often it is, again, hours, and sometimes even days if you have like terabytes of data. And then the team that is supporting this, operations of backing up, of expanding, of they quite often do it manually, and quite often, well, not often. You always pay them some money. You always pay them money to actually support that thing. And if you compare that money and the amount of risk, that amount of time to market that is lost for waiting for these people, and then compare that to the cloud, then the price is a bit starting to look a bit different, because yeah, that's where you're actually starting saving money. So and I mean, I've seen companies which actually support their bare metal infrastructure, and they are effective at that, and they actually for their use cases, it's working pretty well, but at the same time they have skills to maintain that and give the business the value that the business needs as fast as they can. In that case, bare metal is cheaper. But if you lack the skills and you lack the capacity of introducing those skills, then it's cheaper in the cloud.
I think what I've seen in many large companies in the past, let's say 2 years, it's been when they made this decision to switch to the cloud, they typically stayed with their own management of bare metal, but added something like, I think Redshift is called, the Red Hat.
The OpenShift.
OpenShift, yes. On top of their own bare metal. And this kind of gives the best of both worlds in the sense that you manage your own thing if you have the skills, but you also get to the developers the faster feedback, faster deployment, easier deployment, because they can manage the deployments themselves and so on. Have you seen this, or it's
yeah, actually that's what that's the next step, that let's say the company was trying to move into the cloud, and then they realized they still have lots of bare metal resources that they still support in their data centers, and they cannot fully move there, so they're kind of trying to jump into the hybrid cloud infrastructure. And there are several offerings out there. The OpenShift was the first one, was trying to bring this functionality to the companies. I think they were not really successful, and I know that some companies were using OpenShift, but I'm not sure how successful it is, because I haven't really seen that in my clients were not using that. I've heard that some were using that, but not in the area where I was. But now people are kind of with VMware, and with there's another virtualization product called Nutanix. They actually are trying to sell you this hybrid hyper-converged infrastructure with hybrid cloud integration, where basically they build you an abstraction layer like a private cloud, which allow you to use your existing bare metal resources, your existing data centers, and integrate them also with existing clouds. But the developers or the people who are using the infrastructure, they don't really notice, they don't really care what is behind that. And that's becoming, especially for big companies, that's becoming really the way to go. Because for certain types of loads, like for high performance loads, they really need something that is very close together and like maybe in the same network segment, and they're very co-located, and where they maybe have huge amount of traffic that they cannot really put outside, maybe also for security reasons, and then they use this for on their own premises, on their own data centers, and all the rest, all something that is not security sensitive, not something that's not maybe that much performance sensitive, they move it to the cloud. And actually, to address another point that quite often people are trying to say that cloud is slower than on-prem, and to be honest, it is slower. So the cloud resources, you will not get as much performance per dollar as you would get from bare metal, obviously, because cloud infrastructure is virtualized. But on the other hand, what I found out is that many people don't really understand what are their performance requirements. They don't know how much performance they actually need. And sometimes they want like the best performance possible, and they kind of stick to their bare metal just for that reason. But quite often they don't need that performance. They don't need that much bare metal capacity or network capacity that they actually use. Because and another problem with with bare metal, especially if you overbuy that, if you buy too much, is that it's still there. You paid for that. You paid for the capacity that you don't use. And cloud kind of gives you the ability to kind of shrink or to expand capacity for your capacity needs, and you can expand and shrink depending on maybe some seasonal requests, maybe some other like things that are happening in your business, and that's what bare metal doesn't give you. For bare metal, you pay for that, you install that, and it's there, and it doesn't care if you use it or not. It's just there. For cloud, you can have different strategies, and that's what I've seen actually in one of my clients. They are, well, it's a big company, a big insurance company. They are migrating from bare metal into the serverless world. They really are trying to write most of their new applications, at least, using serverless paradigm, serverless cloud native abstractions that cloud providers give them, and they really save a ton of money on that. So and that's another thing that happens in the companies, that they really when you ask engineers that are supporting the infrastructure about different aspects of bare metal or cloud, they talk about performance, about security, about data capacity and stuff like that, but they never talk about, do we really need that capacity? Do we really need the capacity that our applications are running? And quite often they don't. Quite often they overpay for having lots of disk arrays and lots of CPU cores which are not used, or used in a very weird way. And sometimes you can optimize application architecture to be way more efficient, like be event driven, be designed in a small services and deployed into the cloud using cloud native primitives that allow you to save tons of money, and at the same time giving you enough performance.
I will come back to serverless and cloud native architecture, but before that, yet another challenge that you have with typically with automating configuration, you have a lot of passwords, a lot of SSL keys and certificates and all kinds of things that are meant to be private. And yet what we say is that everything related to infrastructure should be in Git, ideally, so that you can take everything from Git and create your infrastructure. But you cannot add the secrets there, right? So how do you deal with these things?
Well, there actually are many options. First of all, you can encrypt secrets in Git. There are several solutions for that. So you can actually you use Git hooks to encrypt the secret when you commit the secret code into the repository, and then when you check out, it will be decrypted for you automatically. So for you, when you're working with the code locally, you will just work with the same plain text files. but when you send them to Git, they will be encrypted or decrypted, and then, well, the Git history will be fully, like, no, not fully, but some files will be encrypted and will not be visible if you don't know the password. And then obviously the password should be available to you, or to the team members who are working with that, and to the pipeline, to the automation pipeline that delivers that code into actual target system. That's one thing. That's one way to do that. Another way is actually try to isolate the secret management from infrastructure delivery. So use maybe some tools that are automating. Let's say if you need HTTPS certificates, you definitely don't need to store them in the version control. And for example, with tools like certbot, or with Kubernetes, like with tools like Cert Manager, you can automate. And especially with tools like Let's Encrypt, you can automate this provisioning and get the certificates securely and quickly, and they will be part of the environment. So environment will automatically deliver the secrets of this type into your system. You don't need to manage them or store them or keep them and stuff like that. Also, there's also other systems like HashiCorp Vault, which allows to introduce different types of workflows, how you manage secrets, and basically applications are responsible for retrieving secrets at runtime. So basically, I mean, again, your secret management becomes environment thing. So the secrets should be available inside the environment where you deploy your application. An application, when it is deployed in that environment, it will just get the secret from the central location or from some file if it was provided there. So secrets are really moving. Well, as you correctly said, actually, secrets should not be committed to Git in general, especially not to the application code or to the generic template for your environment, for example, that you have described as infrastructure as code. Secrets should be managed differently, and they could be managed in a separate Git repository, or they could be managed through a separate, maybe even manual interface. I mean, security is important, and sometimes you have to sacrifice a bit of automation if you want to get better security. But still, a lot of things are possible, like with automation tools like HashiCorp Vault, for example, or just with automatic scripts like certbot or cert manager, stuff like that. But essentially, the secret management becomes the thing that is discovered when you are running inside an environment, when you deploy your code into the environment which is supposed to be pre-configured for running that application. So that's how it happens.
All right. Now another question is to go back to serverless. Serverless is a great idea because it reduces some of the costs, as you said. You pay only for what you use. You don't care about infrastructure as much, in the sense that it's all provided to you somehow by magic, or at least it looks like that. But then you also get very dependent on the primitives that the cloud providers offer you, right? If you write AWS Lambda, I don't think you can port that to another system easily. So there are these advantages and disadvantages. What is the current image of serverless today? What are people doing from what you see?
Well, there's a lot of, because one of the first like function as a service offerings was given by Amazon. Was AWS Lambda, and they actually kind of trying to lead that space now, because they also offer a lot of things that are possible in Lambda functions in Amazon, and actually there's a huge community behind that. That creates different architectures, different applications with Amazon Lambdas, just splitting out, the application code with small microservices that are interacting mostly through event mechanisms. And of course, it would be hard to migrate these kind of things into other clouds, like Google Cloud, for example, or Azure, or maybe IBM. And it's still I would say that there's this field of function as a service, because function as a service it's only part of serverless. It's quite often people put an equality sign between function as a service and serverless in general. But of course, developers mostly focus on function as a service, and they also kind of call it serverless because it's closer to them. But serverless itself, it's actually it's not just that. Actually, it's the term that I like better is called serviceful. So you get lots of services that you have to integrate together. And it's a database as a service, messaging as a service, file system as a service, whatever as a service, and you have your code that is integrating these things together. And this field is relatively new. And of course, every cloud provider is trying to give their own flavor to that, give their own like new features to that. And of course, we have like stateful functions, like step functions, and in Amazon, and also Azure offers that. And we also have like cron expressions. We actually have like a cron job written as a Lambda function, which is a kind of cool thing. And I mean, there's a lot of things that are possible, but you can also see that the primitives are actually more or less the same. We have events, we have files, we have functions, we have cron jobs, we have maybe some sort of way of exposing this like things as web services, as web endpoints, and the amount of functionality is pretty much the same. It's different in terms of usage, of course, and then like the way they call them and the way they kind of configure them. But I think that eventually we will go into the state where there will be some sort of standard that will allow us to compose common primitives. Like if I need a queue of certain things, and I want just to listen to that queue, that like one consumer and producer. I mean, it's a common pattern, and I want to deploy it to the cloud. That will be of course, there are already easy ways to do that, but there probably will be even easier way to kind of take the same code and migrate that between the clouds. And actually, there are several frameworks that kind of try to achieve at least partially that. And one of them is called serverless. The name is kind of a bit unfortunate because they kind of took the idea and named the framework using the same idea. So it's kind of now again people may put a equality sign between the framework and the term, even though they're not quite related. But the serverless framework, so serverless.com is kind of trying at least to serve to some extent that you can partially reuse some of the things, some of the components, but you can have the same code and kind of deploy it in different clouds. Another thing that's happening is that people are kind of trying to build different primitives on top of Kubernetes, like Knative or kubeless, which are giving you this primitives that serverless environment gives you, like function as a service, event management, logging, monitoring of automatic monitoring of the functions, exposing them to the web. These frameworks kind of give you ability to deploy to any Kubernetes cluster to deploy kind of function as a service. And in that sense, doesn't matter where your Kubernetes cluster is. Is Amazon, is your on-prem, or is it some other cloud? And just use the same framework, the same code, and you deploy that code anywhere. This kind of things are also happening. But I think it's still, well, it's already relatively mature, but also at the same time, some of the concepts are still quite early in their development. So maybe next maybe 1, 2, 3 years, we will see some common frameworks that will try to unite these things even more, and we'll try to build the frameworks around common abstractions like queues and functions and cron jobs and stuff like that. And then developers will basically just use that framework or a set of frameworks and deploy scalable applications directly into the cloud without involvement of any DevOps engineers or sysadmins.
Yeah, that sounds really interesting, and this is developing right now, and you can see a lot of new offerings around this. I'm following AWS, and it's quite impressive how many services are rated on a...
Yeah, well, I think AWS have too many. They have too many.
It's starting to get. I mean, initially it was kind of like an operating system for the cloud, but now it's getting even more. It's getting into application territory. But you mentioned the K word, and I think we are mandated by internet law to talk about Docker when we talk about DevOps, because otherwise it's impossible. I have actually a very specific question about Docker. I don't want to go into a lot of details. My initial understanding of Docker was that its particular usage would have been that I, as a developer, when I write my code, I can also create the bits of infrastructure that I need, and this is the container that is then moving through all the levels of through all the pipeline of continuous delivery, and it ends up on the server already tested from the beginning, because I already tested what I needed and so on. But then different people can add more things, like sysadmins can add more configuration, or security people can add more security, and so on and so forth. But it doesn't seem to me, from what I've seen, I'm not very up to date to it, but it doesn't seem to me that we've reached this stage. It seems like Docker is still something that you kind of create for yourself. It's still a bit clunky. It's still a bit difficult to use. What is your opinion?
Well, depending on what kind of operating system you use. I mean, if you're using Windows or if you're using macOS, then there could be some problems using that locally. Yeah, because in integration, it's not. Well, it's improving absolutely, but it's not brilliant. But if we're talking about Linux, and we're running most of production systems, as far as I know, for my clients, actually they're running Linux. And in there, actually, Docker is quite a good thing. But you know, and also Kubernetes is the only way you can run things in Kubernetes is give it a Docker image. There's no other way to do that. And Kubernetes is quite popular as well. And also, Amazon is offering this service called Fargate and ECS, Elastic Container Service, where you can run containers even without knowing how many servers are behind the scenes. They will just give you abstract ability to run containers, and of course it will be Linux containers, and they are pretty stable, I would say. Addressing your point about that, like security people can add something on top of that, like maybe sysadmin can add additional configuration. Of course, I mean, Docker image is just a package, and your pipeline obviously should be doing all these things that like adding extra code or adding extra configuration, and then automatically testing that should be part of your pipeline. They should be automated. And if it's automated, I mean, it's already good. Then you're probably catching like 99% of the errors that could have happened based on the changes that you do to the code or the configuration or the security settings and stuff like that. So yeah, the pipeline is the king. Whatever package you deliver, whether it's a zip file or RPM or Docker image, if the pipeline is configured in a way that it's validating that and building that, then I'm fine with that. It's going to be good. As to the running of that, there are, I mean, depending on whom you ask, because if you ask developers and if you ask people who are just running applications, then Docker is awesome because it just works. If you ask sysadmins, and especially if you look at the history of what's happening with Docker as a company, actually they're not that fond of the Docker engine as it is, because it's kind of using some of the old versions of control groups, some of the old versions of the libraries, and you probably heard of some fluctuation that happened with Docker company. They sold they sold Docker Enterprise to a company called Mirantis, which nobody heard of before, but now people know about that. And they decided to focus solely on the Docker engine. And financially, Docker as a company, as far as I know, is not doing super great. That's why they had to sell part of the company. And that's why they couldn't actually focus on the engine too much, because they were focusing too much on trying to make money, which they kind of failed. And also, that's why there's a lag of updating to the latest features of Linux kernel. And there are some alternatives that are starting to appear, which allow you to create containers, but without Docker. It's called Podman, for example. Also, our RKT was Rocket was also existed for some time. I think it's still valid, but not that actively developed. Probably some certain things will happen in this space. Maybe we'll hear about new engines and new standards. But to be honest, Docker as a product, if you look at like the command line option the Docker offers, or the features that we have inside the Docker engine, I think it is relatively stable, and I don't expect too many features to be added to that product in the long run, because people don't need more features there anymore. Because at some point, Docker as a company was trying to create a product that is everything for infrastructure management, configuration management, for secret management, stuff like that. So basically, they started to build in features like services, stacks, secret management, some other things that actually were also implemented by Kubernetes. And it was really unfortunate that Kubernetes became so popular. Maybe if Kubernetes didn't happen, then Docker would feel slightly better. But because if we look like it, that what the Docker as a company tried to put into the product, they probably tried to put too much. They tried to do everything. Try to have the enterprise version. Try to have common patterns for like that Kubernetes was implementing already. They tried to also build their enterprise version, and also try to be the only authors of the core, and that I think that kind of made them very bad fortune, and they kind of didn't succeed. So now Kubernetes is there. Also, there are some alternatives to Docker that are appearing, and some hardcore sysadmin kind of don't like Docker because it's not performing as it should be performing. And but in general, I think now, after Docker as a company sold part of that, and they really focusing on the engine, I think maybe within a year, maybe two, the product will be becoming super stable. I mean, it's already stable, but it will be even more stable, like very solid and very, 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 very stabilized.
Yeah, I mean, I don't know. One thing that I found a bit difficult, perhaps I didn't find the right integrations, but if I'm developing, like, say, a web application or a script, it's much easier for me to kind of do a Vagrant virtual machine deployed to that, or it's already actually quite easy to share folders there, and then pack everything, since I'm using Linux most of the time, pack everything in a deb or RPM and deploy it like that. And it seems like it's much easier. It's native to the system. It's also a longer tested system with debs and RPMs. It gets all the necessary dependencies. But perhaps it's my personal experience and not a general view of.
Yeah. Well, when Docker only started, like maybe like 2014, 2015, I was using Vagrant quite a lot, and I was kind of why should I use Docker? But then with time, I kind of it gave me some benefits, especially because I'm starting to writing like smaller applications, something that is easy to test locally, or easier to just package into an image and run that quickly. Then Docker actually was quite handy for me, and I find myself that I'm not using Vagrant that much anymore. Sometimes I do, but like for very specific use cases. But in most of the cases, Docker is enough. And also, recently also, not recently, maybe also a couple of years ago, because I'm using Windows mostly, and Microsoft released this Windows subsystem for Linux, which basically is a small Ubuntu, or actually now you can even get other distributions with all the Linux tools. So and basically it's a small virtual machine running behind the scenes where I can install whatever I want. And that also made my life a lot easier. Before that, I was running some of the tools inside Docker or Vagrant. Now I can just jump into the WSL and do things in there, especially for tools that are not natively Windows. It's quite handy. Right. But also another thing is that it's becoming cheaper and cheaper to run things in the cloud. So sometimes if I need a test environment, just I created that one in the cloud, and that's enough.
Yeah, and that's actually another thing that I noticed with companies whenever we come or they want to do some kind of agile transformation, and of course part of it becomes, or one of the bottlenecks is actually lack of infrastructure automation or lack of continuous deployment pipeline. And one of the things that I notice is it's very difficult sometimes for them to create a secondary test environment. So they often have the production environment, and then things are tested somehow in a limited pool of servers, but to create almost a full duplicate of the existing infrastructure, that's very difficult. Have you seen this, and how do you deal with such situations?
Yeah, definitely seen that. But usually, as I mentioned, I mean, it's because of accumulation of a lot of technical debt and risk that people didn't pay attention for years, and then they ended up with an environment that is not reproducible in any way. And there's it's a unique set of configurations that you cannot really capture and reproduce. There's not enough or lacking documentation, and there's no code that describes that. There's nothing. So obviously, and maybe the people who actually set it up already not working in the company. Yeah, definitely, I've seen that thing. And I mean, the only way you can actually address that is start by implementing something that you probably know. This is strangler pattern, when you take part of the system and you kind of implement a new version of that, and then try to switch between the old and new part slowly. And by doing that, you kind of try and capture the knowledge of the old system in the infrastructure of code, and try to also automate the pipeline and stuff like that. So that's the only way to do that. Unfortunately, you have to discover the knowledge that was lost there during the years. And the only way to capture the knowledge is describe that as code. That's the only way.
Yeah, and this also leads to expenses, because you need to in order to do that, you need additional servers and additional systems and so on. All right, this has been very interesting, and we are getting closer to the end. Before I have one final question for you. Do you have anything that you'd like to tell our audience about you, about what you are doing, or what they should be doing with these ideas?
Well, my main kind of message would be that if you're working in the area of automation or infrastructure, try to make yourself replaceable. Try to make yourself redundant, not needed, because that will, first of all, will fulfill your job, and will actually allow you to focus on things that probably are more important than doing backups at 4 at night and stuff like that. So make yourself replaceable. Try to automate as much as you can. That's the main message.
That's a cool message. So I like to ask this question to everybody who I'm talking to. It's in today's world, if you are a junior developer, there's all this buzz about a lot of things that I didn't have when I was starting as a junior developer. When I started, it was Visual Basic or Visual C++. That was fundamentally the choice, and you would go with one of those. And but now you have all these different frameworks and technologies and stacks, and in addition to that, you have the cloud, you have DevOps, you have so on. So for a junior developer, would it be interesting to look at automating infrastructure? And if so, where would you start?
Yeah, it's a good question, because yeah, I definitely don't recommend starting with Amazon, because it's very complex. It has lots of things that you probably will find very frustrating and not really understandable. On the other hand, if you really like difficulties, and if you really like diving into the core of that, then Amazon is the way to start. So depending on type of character you are. and type of learning that you prefer doing. Either start with Amazon, don't start with Amazon. Start with a simpler cloud, like something like DigitalOcean, for example, or Google Cloud, which usually is easier to grasp. But definitely learn cloud primitives. Learn the things that are available in the cloud as a service, and because most likely you will be building software on top of these primitives in the future, and most likely already are building.
And by primitives, you mean things like databases in the cloud, storage in the cloud,
services like abstractions.
tools.
Yeah, exactly. Like, anything as a service, like storage, the network, security, secrets as a service. So get used to this. That a lot of things that your application will be using in the future will be provided by somebody else, and you have to be able to integrate these things and also understand maybe the SLAs behind the scenes. What are kind of you always have to understand what are the risks behind using different types of components, and usually cloud provides like the lowest risks, but you still have to understand them. You still have to understand what kind of risks are there behind the component that you're using.
And if I want to script something that's simple, I don't know, deploying WordPress to the cloud, or some kind of things
simple.
like that.
Keep it simple. That's.
But what should I start with? Should I go with Docker? Should I go with some kind of simpler things?
That's a good question, because I think Docker. Well, I mean, it's essential tool nowadays, but Docker will become like a minor detail in the future. So knowing Docker, I mean, maybe knowing the tooling is important, and maybe understanding the the UX of Docker client is important, because many other tools are actually trying to copy the usefulness and the easiness of using Docker client in their own tooling. And like if you look at some of the cloud automation clients that are available there, some of them are like so obvious, so easy to understand, that it's important that the people who are implementing new tools or using these tools, they expect this from their tools, and implementing this kind of easiness, simplicity into their own interfaces, into their own applications, because that's like the simplicity is more important than Docker, for example. And I mean, I like Docker in a way that it changed the world of automation, not because it introduced containers and some hardcore Linux features, but because it introduced a different user experience or developer experience. And basically, if you're choosing a new tool, seek that kind of experience from them. And if they're not giving that, then probably it's not a good tool.
Okay. All right. Thank you, Andrey. This has been great. Where can people find you if they want to find out more about? You have talks on YouTube, you have trainings, are you writing blogs? Where can people find?
Well, I'm on Twitter, obviously. Yeah, I'm making my training from time to time, which is called Extreme Automation. So if you go to extremeautomation.io, you can find me. But also, I mean, honestly, my name is pretty searchable. So if you want to find more about me, just Google it. It's Andrey Adamovich, so it's easy to find.
All right. Thank you, Andrey. This has been great. I hope you have learned now, for all our audience, I hope you have learned a lot from this conversation, at least more about what DevOps means and where we are with this change. I'm pretty sure that tools and the support will change and develop in the next years. It feels like we are in the middle of something, not at the end of something. So it's something that's worth following in the next years as well. But for us, first of all, we have to pay a bit our dues to the algorithm. So if you like this conversation, please share it, like it, subscribe to our channel. And we are coming back with new and interesting conversations. So until next time, remember to think, design, and work smart.